So this question is about parallel plate capacitors and comparisons between them. So again, you can use the data and formula book to give you that the capacitance is given by the area of the plate multiplied by the permittivity of free space, or the permittivity of the vacuum, and multiplied by the permittivity of the dielectric that you have within the material. And this is the thing we're interested in for this question, and then the separation of the plates. And we're told that for these two different situations, these capacitances are the same. So in situation one, the capacitance is C, but the area, we have square plates length L, so the area is L squared. And then we're told the distance is D, and we've got epsilon naught, that remains constant. And then we'll call this one, we have a dielectric, so I'm going to call this epsilon D for dielectric, and then the separation is D, and that equals C. Then we look at the second situation, equals the same C, but this time the plates are 2L, and 2L squared is 4L squared, epsilon naught, and this time we're going to have epsilon air. Okay, so air is the dielectric, and then that separation is different as well, and it's 2D. So we have the relationship where this value equals L squared epsilon naught, epsilon of the different dielectric over D. L squares cancel, L squares cancel, epsilon naught cancels, epsilon naught cancels, D cancels, D cancels. 4 over 2 is 2. So end up with 2 lots of the epsilon air is equal to 1 lot of the epsilon for the dielectric. So relative term permittivity of the dielectric in the first capacitor. So in the first capacitor, we're interested in the dielectric, and that is 2 times the permittivity of the dielectric in the second situation. Get that the right way around. Relative permittivity in the first capacitor, so that's the first capacitor, which is the D value, and it's twice that of